In this video, I'll create a small web application using Solid, TypeScript, and Visual Studio Code editing a Node project. The prerequisites for following along are Node and Visual Studio Code. Now, the quickest way to start a Solid TypeScript project is with the npm command as shown in Solid's Getting Started section. Now this command creates a Node project with TypeScript source for a starter web application. It's a great place to start, but the build process is implemented by scripts provided by a dependent project called Solid-Scripts, and I needed more flexibility, so I created a Node project with the toolchain more explicitly defined with configuration files. There's a link to this starter project based on that work in the video description. You can copy that and use it as your foundation. Now it's, kind of the first sophisticated Node project I've created. So if you're an expert, you may, find ways of improving it. But it works as a good starting point. So I opened a copy of this, the just mentioned starter project here in Visual Studio Code. It contains a TypeScript version of the JavaScript code for the previous project. You can review the source yourself, but I'm going to delete most of it to create a new application that shows a couple of buttons for changing the color scheme. So I want to open the terminal window from within Visual Studio Code, which is View Terminal. And down here, all right, so with any Node project, here's the package.json with all the dependencies that it specifies. And the first thing you need to do, is npm install. It downloads all the dependencies into the node_modules folder. Now the scripts section of the package.json file shows what npm commands the project defines. Open. The open command starts Webpack's development server and opens a browser pointing to that web application that it serves up. And it also, it'll perform a hot reload when any source files change. So once the dependencies finish, we'll launch the application just to see that it's working. But we're going to replace this app with a new one, so mostly delete everything. All right, so it finished downloading the dependencies. So now we'll try npm run open to start the Webpack development server, and it should open a browser. Okay, and you can see that it's the little app that I had shown in a previous video inside of Code Sandbox. But this one has, it's kind of rewritten with TypeScript, and so you can look at that project if you want. All right. So I'm going to leave this running because we'll check back. It'll do a hot reload when we have a working application as we change it. All right. So in app.ts, let's delete everything in there. And in index.tsx, all right, so I'm going to save both of these. And you can see when I do down here in the terminal window, it does a recompile. Actually, let me make the code bigger here. So it's a little too big. All right. So let's go back to the browser window. And, all it's showing is the word test. So it's very, all right. So this application will have a few buttons that let you change the color theme of the whole application. I created a basic layout in JS Fiddle, which is let me run this. So it's it's just a simple list of buttons and some text, and there's a button for changing the theme to light, one for dark, and then custom will grab the colors out of these three input boxes and use those. And so it's a silly little application, but it'll show some things with Solid. All right, so basically I want to I'll paste this into the app source as a starting point, basically, but I want to move the buttons into their own component called button bar. So that will look like this. So here's the app component. We'll replace it with this. So this is basically the HTML from JS Fiddle, but the buttons, the main app references the button bar and then has the paragraph. And then here's the button bar component with just the buttons. Now we want our button bar to take arguments. Specifically, we want the button bar component to invoke callback functions provided by the parent component when buttons are pressed. So let's look. So when we invoke the button bar, we want to be able to have callbacks that are invoked. So eventually we will pass functions to those arguments, but for now let's just see how to modify the button bar to support these properties. So we need to have a props argument and reference a member from it. So we need to create a props argument, and then let's just look at the light button. We'll change it to, let's say, on click equals, and the event, the mouse event we don't need, but we're going to call props.onLight click. Okay. Now you notice that when we were filling in this on click, the IDE helps us see what on event properties are available to us with the standard components like button. And that's really nice that's Visual Studio does that for our JSX. Now the errors here are because, unlike when we did this with JavaScript, TypeScript needs to know the type of the single props argument. So I'm going to get to the correct solution the long way to show a little bit of the TypeScript learning curve I went through. So we could try to fix it by adding a type annotation to props this way. To give props a type, basically saying it's an object with an onLight click property, and that fixes that. It knows that props has that value in the object. But here's this error here, and we have a conflict because the component type right here also specifies the type of props. And the error is kind of long, but basically there's a conflict between components declaring a type of props, and then we specify our own type, and there's a problem there. So when we look at what component this type alias, it means that component is a type alias that takes a generic type P, defining a function with a props argument of type props with children of P that returns JSX.element. The type annotation for button bar is simply component without a type. So you can see from the definition here, it defaults to an empty object. So let's this is interesting. So what is props with children? So if we look at, I searched Solid's repository for the definition of props with children, and it's defined this way. So props with children is a generic type, and it's basically saying that props with children is the same as P, but it also adds a child value to the object of type JSX element. And that's because every component in JSX can have children. And so when you define a component, it's basically saying, tell me the type of your props object, but I'm going to add to the props object the children, member. And, our button bar doesn't have children, so we're not going to reference it, but every component has the, basically will get a child element declared, which you can use if you need it. So since the type annotation for our button bar component specifies the type for the props argument, we don't want to add a type annotation to the props argument. Right, the component is conflicting with this. So the correct way to do this with Solid's component type alias is to specify the type of props in the generic type argument by passing, the P type. So we will change it to this, right? So to the component type, we say it gets an object with an on-light click member, which is a function that takes no arguments and returns void. So you can see that props is, props with children of that type. As you probably guessed, if the component has a lot of properties, right, you're going to pass, we want to pass at least 3 into here. This type here is going to get kind of long. So let's define a type alias for it. And then we'll replace this with button bar props type. All right, so now there are no errors here. This is saying the button bar is a component and the properties have this type, button bar props type. So let's define 2 other button bar properties. All right. Oh, the case wrong there. All right, and so this the custom button, the custom button right there, it must grab the strings from the 3 text inputs and pass them to the callback. It's possible to grab the text from the inputs by looking them up by ID, but Solid provides a direct way to do this. You declare a variable for each control and then reference it in the JSX. Let's see here. Spot. So the inputs. So I kind of wrap this weird so that it fits on the screen nicely. But so we declare a variable for each control right here. And then you use this ref option that Solid provides, and that references those variables. And when it renders these controls, it's creating them, and it will then assign these variables to, basically refer to those DOM nodes. So you basically have a direct access to those DOM nodes. But we haven't given these variables the right type yet. Resting the cursor on the ref property, gives us a hint that it should be an HTML element or HTML input element. The specific type will be more useful. So let's do that. That way, when we reference them, we'll see all the proper properties that those variables have. So now it's complaining that the variables are used before being assigned. The compiler doesn't know that the compiled JSX code will assign them before we reference them in a button click event handler. But we must make the compiler happy. Rigorous code is good. And I'll admit that I went down a long path trying different ways to solve this problem. I tried defining these as HTML input element or undefined and assigning them to undefined. But then when I used them, I needed, a lot of type guards and a lot of extra logic that was unnecessary to deal with the possibility that they could be undefined when I'm confident that these variables will be assigned by the compiled JSX code before they're referenced in the button click handlers. So this is a case where I know something that the compiler doesn't and want it to trust me. I found a way to bypass TypeScript's careful type checking in this case, and I want to leave the input controls as the single, proper type of HTML input element, but assign them to undefined to get rid of this error about them being referenced before being assigned. And the compiler has no way to know that, they'll be assigned. I already said that. So initializing them to something, will make the compiler happy. So let's see. Let's do this. All right. So this is maybe wrapped a little bit too much. So this, I first tried casting. So the as, right? I want to assign these variables to undefined to get rid of that error. But you can't assign an undefined to an HTML input element. But by typecasting, I can tell the compiler, just like in other languages like, C or C++, you can say, I know what this pointer is, and, you think it's pointer to this, but you can typecast. So by saying undefined, I want to say undefined as HTML input element. That would let me assign it to what it thinks is an HTML input element, getting rid of that warning. But there was this, the compiler reported an error when I tried to go straight from undefined HTML input element, something about the types not overlapping sufficiently. And luckily there was a suggested fix of first, typecasting it to unknown before then converting to HTML input element. And so it may look a little strange, but remember, this is all just typing that gets removed from the JavaScript code. And now the compiler is happy. And this is an odd situation, and there are other ways to solve it, but I think this is efficient and robust. It just looks odd. I saw a discussion that the need for this, double casting may be removed in a future version of TypeScript. Now the code now declares 3 variables that Solid will set to references to the DOM elements when the input DOM elements down here, when the component is rendered. The custom click handler will pull the text values directly from those input elements. And the underscores for the function arguments are convention indicating, that we aren't using these arguments. In this case, we aren't using the mouse click event object. So let's see if these callbacks work. So we'll go, where do we reference the button bar? So we're basically putting in console logging by the parent. So basically when any of those buttons are pressed in the child button bar component, right, they're going to invoke the callback functions that are passed in. And we're just saying those callback functions are going to log the values that are passed to them, or some of them don't take arguments. So let's see if this works. Let me save it. And it compiles. And our app looks better now. So let's open up the development tools. Make this a little bigger. And go to the console, clear that. So if we click light, dark, and custom. So, that's all the callbacks are working. So now let's delete this store because we're going to create a new one. So I'll right click on the source folder and say new file, and we're going to call it settings store.ts. I mean, it's a store, but we may have another one in the app, so we'll call it's the settings store. And it's just going to be a class. And I think a class makes sense for managing the store in TypeScript or the state. I like the class syntax. So in the constructor, we'll call the createState function. And when we call this from JavaScript, we only worry about type so far as the code needs to work. With TypeScript, many external libraries have support for TypeScript, and Solid is no exception. So if we rest our cursor on the createState function, we see that it has a signature which createState is a generic function that takes the type of the state object. And so the cleanest way to code this is to define a type alias for our state. So let's do that here. Right, and our state is going to have for this little simple project, we're going to have a state will contain the color for text, the color for the background of the text, and then the color for buttons. Let's change this state to use that state type. So we'll deal with the default state object in a second, but we want this class to expose the state variable as a public instance member. And we want to store the setState function as a private instance member because we'll create public methods for updating the state. Notice the types of these two values returned from createState. They're defined as generics based on the type of our state object. So it returns a state of state type and a setState function of state type. All right. So then the whole thing okay. Sorry. So I've defined a public state, which is of that type, and the private setState function of the right type that matches what Solid returns. And then I changed this to this dot state and this dot set state so that it sets these two instance members to store those values that are returned. And so let's just paste in a few remaining lines to create 2 private and 3 public methods. Right. So the 2 private methods return, they simply return the color values for the light and dark themes. So now so we can use one of these. Let's make light our default theme. So in our create state, we'll just call this.get theme settings light. Okay. And the public functions are, if you want to set the theme to light, you want to set it to dark, or you can set it to a custom where the colors are passed in, and it will then, change the state. So that's all there is to that. So we're ready to create our settings store and use it in our components. We could create the settings store in our app component, but to simulate a scenario where it's also used in other components, let's create it outside of our component in index.tsx. So we needed to import our settings store class, and then we're going to create an instance of it. And then we need to pass it to our app. We're going to say settings equals settings. So this will pass the settings store object to our app component. So now that our app component takes, let me save this. Now that our app component takes an argument, we need to define a type alias for the props argument and use it in the component's type annotation. So we're going to import the settings store because that's, we need to know that because that's what's passed to us as settings. Right, this is what we've seen before. Is we want to say our app component takes a type of app's prop type, and then so props is all right. So now the app component can invoke methods on the store to reflect theme changes instead of logging into the console. So we'll change our callbacks here. So now when the button bar signals an on light click event, we just simply call the set theme light in the settings, and on dark, we call the dark. And the custom, right? The custom is past the 3 colors, and we just call the set theme custom method on the settings object for that. All right. So now let's style our app component to use colors from the settings store. So I haven't saved the store, and it compiles. So let's go look at I'll close the debugger tools. So we set light, dark, custom. So the text is dark blue, and the buttons haven't been styled yet, but the light, dark, custom. All right. But we must still style the button background color. So if the button bar is a reusable low-level component, we probably don't want to have to know about what the settings store is. And so we want the parent component to determine where the background color comes from. So instead of passing the settings store to the button bar, we'll just pass a property that specifies the button background color. So where we invoke the button bar, we're just going to pass it button color, which comes from the state, which is already there. All right. But the button bar doesn't have that property yet, so we'll add that to the type defined for the button bar props. And that gets rid of that error up there. And now we will change the buttons to have a background color that's taken from the past props. Okay. So I created this function, getButtonStyle, that returns an object which specifies background color taken from the button color passed in props. And then each button has style equal, and then we call that function to get the style. All right, so when I save this, compiles, let's look at whether light, dark, custom. Yeah, so light and dark. Yeah, it's hard to tell, but it does change to be a little bit darker. And then custom, right? Button is orange. So now that's working. This kind of works unexpectedly. You know, I did not expect this to be reactive. Because when we pass in, let's go back up to here, when we pass in, right, we're saying pass in the button color. I would think that it's going to go fetch the button color as a string and then pass it to button color, right? We're not passing a function that returns a color or anything that would make it reactive. We're just passing it in. So, you know, why does it work? Why is it that it doesn't just take a string? So let's look at, we'll search the source. So we'll go to the app here, open the developer tools, and we'll go to sources, and we will search for, so we do Control-Shift-F, search for props.settings.state.button color and see how it's passing it in. And so I think this is the code where it's, you know, this is where it's rendering or it's invoking the button bar component and passing in the callbacks or the button color and then the three callbacks. You can see that it's actually passing in a getter. So that's why it doesn't just, you know, grab the value out of the state and then pass it. It passes a getter, which returns that. So that's what makes it reactive. So that's very clever. So, you know, that's cool since, you know, the type of the value is passed in as a string, but it's reactive. So, so when each button is rendered, the style is determined by a call to get button style, which references props.button.color, which is a getter function that returns the color from the setting store state, making it reactive. So, so I noticed that if you pass a plain string expression to button bar, it doesn't wrap it in a getter function, and so it, the JSX compiler must somehow see that this is it makes sense to wrap it in a getter to make it reactive, and it does that. So that's kind of an unexpected cool thing. So there's one thing I'd like to change in this project. Let's go back to the project. So each component that takes a props argument typically contains many references to that argument. Right, there's props, props.setting, over and over. And I like to use object destructuring to succinctly extract the members of props into separate variables. And if you aren't familiar with object destructuring, I'd recommend learning about this powerful feature. So let's change the app. So what we do is instead of, because I think if we look at all references to props, we grab the settings. So instead of, so to do the object destructuring, we do this. And that says get the settings value out of the object and set it to a variable called settings. And then we can get rid of the props dot in all these places. Oh, there's the other one. Probably a quicker way to do this. But that just kind of shortens up that component. All right. So save this, it compiles and everything will work the same. So now the button bar, if we look at where props is referenced, it's referencing a bunch of different things. So you can see that if I hit Control Space in Visual Studio Code, it helps us out. We have button color we can extract from the object. We have on custom click, on dark click, on light click, and children. Well, I got to do all of them. On custom click, on dark click, on light click. Okay. So then we'll change the props again. All right, that just makes it more concise and not repeating props everywhere. It kind of grabs. Okay, so now it compiles. So let's go and look at how that works. Right, the button color is no longer reactive. See that it's not changing to orange. And so why is that? So I see that, button color is still passed to button bar as a getter if we went and looked at the compiled code. But really this makes sense in that, when JavaScript executes, the object destructuring is performed, at the, it basically extracts the values out of the object when the component is rendered. And right, it's basically saying, create a variable called button color and grab it out of the props object. Well, when it does that, it calls the getter that's passed in and grabs a string. And then, right, there's a string variable, which is then used in the button style. Well, that's not reactive. It basically, by destructuring, we've lost the reactivity by calling the getter, up here at the top and not inside when it's rendering the controls. So, I tried different things. You can fix it by making the button color a function that returns the color, and then you can pass in the function that returns the color from the state. But then it wouldn't support just a regular string, a constant. And I tried where I made button color a type that could be either a string or a function that returns a string, and then puts in code where it's used to check, have a type guard to check for the type, and if it's a function, call it. If it's a regular string, just use it. And that's all doable, but it really kind of seems overkill. And so I think just not doing object destructuring when you know that the values that you're passing in need to be reactive. It's just, anyway, it's an issue that I'm not sure if there's a better solution. I couldn't find any. And so kind of have to forego object destructuring in that case. Now we can leave it up here because settings is not kind of the primitive reactive. It contains the primitive thing. So, we can destructure it. We have a reference to the whole settings object taken out of props, and we can use that, and that's still reactive. You just can't grab one of these as, being destructured. So, all right. So there's another idea that I'd like to demonstrate. In my first project where I used Solid, I had a button that invoked an asynchronous operation, and I wanted the button to change its background color to indicate the operation was in progress and reset it when completed. So when the button is clicked, it will invoke the click handler provided by the parent, and it will pass a function back to the parent that the parent calls when the async operation is complete, kind of tell the button, I'm done. You can change your background color to indicate that the asynchronous operation is done. So let's add an on async click property to button bar. And you can see that the signature, it's a function that takes an argument and returns void, and that argument is a function that doesn't take any arguments and returns void. So when it invokes this, the parent's going to pass in a function that when it's invoked, it'll be passed a function from this component. Anyway, I think I already explained that. So so we'll add a new button for this async operation. Add it after the last button. So to make the background color of the button reactive, we'll create a signal. Now a signal is a reactive primitive value. And it's a lot like creating a state, but it's just when you want a single value, you don't want to wrap it in an object. It's just, I just want a reactive primitive. So, and it's used completely internally to our button bar. So we will create it there. Create signal. It knows, had a nice helper, right? It knows how to find it, and did that quick fix, and it adds it to the import. And so it returns, this call creates a signal containing a Boolean with a starting value of false. So create signal is a generic function where it inferred the type of the value, the primitive value we're changing from the type of the argument, and it's a Boolean. And it returns two functions, one that's used to get the value and one that's used to set the value. And it returns a tuple. All right, so we'll need a separate function to set the style for this button. And so, right, this is a function that returns an object literal, which is a style, object to set the background color. And the color is set by calling the getAsync is async operation calling, right? That gets the current value of our primitive signal. If that's true, the background color will be red. Oh yeah, I did. This was from an attempt to fix that problem I talked about previously. So I left that code in there accidentally. So it'll either be red or props.button color that's passed in. So I hope that makes sense. We'll need a function that's invoked when this button is clicked. Because we need to do a little extra logic, so we're not going to just call the callback directly. So we'll kind of we're going to create a function called doAsyncOpClick that will be invoked when the button is pressed. So let's change that. doAsyncOp. That's a function, so we just we can just reference it. So when this button is clicked, it's going to call doAsyncOperationClick, which is right here. It's going to check the state of our Boolean signal. If it's already true, the button's, there's an async operation in progress, it won't do anything. It'll just skip this if statement and won't do anything. So clicking it multiple times while one is in progress, won't start another one. Then it calls set is async op calling, which sets our Boolean to true. And then we're going to invoke the, I'm not sure we're getting an error here. The callback, I need props dot, right? It's passed in from the parent. All right. So let's see if we save this. All right. Oh yeah, of course. So now we need to implement the event handler in the parent. And the parent will use a timer to simulate an asynchronous operation that waits a second before calling the reset function that was passed to it. So let's see, in our app component, right? So the error we have is the button bar was not passed the on async. So what we do here is we're creating our callback because it's right, the signature. So let's just put it in here now. So we'll say, we'll put it at the end here. On async operation click equals, and then we call our handle async operation click function above. Got to make it inside the button. There we go. All right, so this function, right? This is so when the button bar invokes our callback for the async operation, it's going to invoke this function, which is passed this finish notify argument, which is a function that returns void that we will call when we're done. So then we start a timer, and after 1 second, it will then, call finish notify. And I think that we don't need to make this an arrow function because it is a function we can just pass directly that set timeout will call when a second is up. All right. So we save that. Yeah, it compiles. Let's click the async operation. It did not turn red. What's going on here? Oh, get button style. I want async operation button style. Okay. Right. There we go. Missed it by that much. All right, so yep, there we go. Stays red. Make a custom. And it's, one thing that I, sometimes this sort of thing can cause bugs because, let's say you hit the async operation and then change it to dark. Well, if, you had explicit code in there that said, well, if it's dark, set everything to, set their styles, and then the async operation completes and, it then turns the red off. Well, what is, it has to go look up what is the current, color supposed to be and things like that. And it might, if it saved it before it turned it red and then it restored it, but in the meantime, we changed it to light, it would be wrong. So, this, I found that, using state and relying on state to, that it just eliminates all that complexity. You set the state, the components are rendered from the state, and things just work. And let's see, we can change this to, buttons to purple. And we click custom, they're now purple. This is a silly little app, but I hope it demonstrated more of the Solid framework and also how to use it with TypeScript. I'll put a link to a GitHub project containing the resulting code in the video description below. And now the next video will cover some things I learned when integrating Solid into an existing large web application that didn't use a framework.